Fuses and circuit breakers, while both serving the critical function of overcurrent protection in electrical systems, differ significantly in their continuous current ratings. A standard fuse is generally rated to carry 100% of its marked amperage continuously, whereas a standard circuit breaker is typically rated for only 80%. This means a 100 amp fuse can theoretically handle a continuous load of 100 amps, while a 20 amp circuit breaker is designed to handle a continuous load of only 16 amps, which is 20 amps multiplied by 0.8. Considering the practical implications, when selecting overcurrent protection for a panel with a calculated load of 85 amps, a 100 amp fuse would be suitable, leaving a capacity of 15 amps. This contrasts with the requirement for circuit breakers where the calculated load should not exceed 80% of the breaker's rating. It is crucial to distinguish between the continuous current rating and the interrupting rating of both fuses and circuit breakers. The continuous current rating refers to the maximum current the device can carry indefinitely without tripping or causing damage. The interrupting rating, on the other hand, indicates the maximum fault current the device can safely interrupt without failing catastrophically. The interrupting rating is often significantly higher than the continuous current rating. For instance, a fuse might have a continuous current rating of 100 amps but an interrupting rating of several thousand amps. Understanding the distinction is essential for proper selection and application of overcurrent protection devices. When sizing fuses or circuit breakers, several factors must be considered to ensure adequate protection and compliance with electrical codes. These factors include the calculated load, conductor ampacity, motor starting currents, and ambient temperature. Firstly, the calculated load is the total current expected to flow through the circuit under normal operating conditions. This value should be determined by summing the currents of all connected loads, taking into account any applicable demand factors or diversity factors. Secondly, the conductor ampacity is the maximum current carrying capacity of the circuit conductors. The selected overcurrent protection device should not exceed the conductor ampacity to prevent overheating and potential fire hazards. The National Electrical Code, or NEC, provides tables and guidelines for determining conductor ampacity based on conductor size, insulation type, and installation conditions. Thirdly, motor starting currents can be significantly higher than the motor's full load current. When selecting overcurrent protection for motor circuits, it is necessary to account for these inrush currents to avoid nuisance tripping during motor startup. The NEC provides specific rules for motor overcurrent protection, allowing for higher overcurrent protection ratings to accommodate starting currents. Fourthly, ambient temperature can affect the performance of both fuses and circuit breakers. High ambient temperatures can reduce the current carrying capacity of conductors and overcurrent protection devices, while low temperatures can increase the tripping time of circuit breakers. The NEC provides correction factors for adjusting conductor ampacity and overcurrent protection ratings based on ambient temperature. In addition to these factors, it is important to consider the specific application requirements and the characteristics of the available overcurrent protection devices. Fuses offer several advantages, including high interrupting ratings, fast response times, and simple construction. They are often preferred for applications where high fault currents are expected or where precise coordination is required. Circuit breakers, on the other hand, offer the convenience of resettability and can be easily tested and maintained. They are commonly used in residential, commercial, and industrial applications. When selecting fuses, it is important to choose the correct type and rating for the application. Different types of fuses are available, each with its own characteristics and performance capabilities. For example, time delay fuses are designed to withstand temporary overloads, such as motor starting currents, without tripping, while fast-acting fuses are designed to quickly interrupt fault current. Similarly, when selecting circuit breakers, it is important to consider the trip characteristics and interrupting rating. Circuit breakers are available with different trip curves, which define the relationship between current and tripping time. The interrupting rating of the circuit breaker should be sufficient to safely interrupt the maximum fault current available at the point of installation. Proper installation and maintenance of fuses and circuit breakers are essential for ensuring reliable overcurrent protection. Fuses should be installed in properly rated fuse holders and should be replaced with fuses of the same type and rating. Circuit breakers should be installed in properly rated enclosures and should be periodically inspected and tested to verify their functionality. Regular maintenance can help prevent nuisance tripping and ensure that the overcurrent protection system is operating as intended. Furthermore, coordination studies are often performed in larger electrical systems to ensure that overcurrent protection devices are properly coordinated. Coordination studies involve analyzing the fault current characteristics of the system and selecting overcurrent protection devices that will trip selectively, minimizing the extent of the outage in the event of a fault. Selective coordination is achieved by ensuring that the overcurrent protection device closest to the fault trips first, while upstream devices remain closed. This prevents unnecessary outages and improves system reliability. In summary, understanding the continuous current ratings and interrupting ratings of fuses and circuit breakers is crucial for selecting and applying overcurrent protection devices. Fuses are generally rated for 100% of their marked amperage, while circuit breakers are typically rated for 80%. When sizing overcurrent protection, it is important to consider the calculated load, conductor ampacity, motor starting currents, and ambient temperature. Proper installation, maintenance, and coordination are essential for ensuring reliable overcurrent protection and electrical safety. The selection between fuses and circuit breakers often depends on the specific application and system requirements. Fuses are known for the high interrupting ratings and fast response times, making them suitable for applications where high fault currents are anticipated or precise coordination is necessary. Their simple design also contributes to their reliability. Circuit breakers offer the advantage of being resettable, allowing for quick restoration of power after a trip, and they can be easily tested and maintained. These characteristics make them a popular choice in a variety of settings, including residential, commercial, and industrial environment. It's worth noting that various types of fuses are designed to cater to specific protection needs. Time delay fuses, for example, can withstand temporary overloads such as those experienced during motor startup without tripping. This prevents unnecessary interruptions in power supply. Fast-acting fuses, on the other hand, are designed to quickly interrupt fault currents, providing enhanced protection against short circuits and other electrical faults. Similarly, circuit breakers come with different trip characteristics, defining the relationship between current and tripping time. These trip curves are carefully engineered to provide optimal protection for different types of loads and fault conditions. The interrupting rating of a circuit breaker is a critical parameter that determines its ability to safely interrupt fault currents without sustaining damage. It's essential to select the circuit breaker with an interrupting rating that is sufficient for the maximum fault current available at the point of installation. Proper installation and maintenance of fuses and circuit breakers are paramount for ensuring their effectiveness in providing overcurrent protection. Fuses should be installed in fuse holders that are appropriately rated for the voltage and current of the circuit. When replacing a fuse, it's crucial to use a fuse of the same type and rating to maintain the intended protection characteristics. Circuit breakers should be installed in enclosures that provide adequate protection against environmental factors and physical damage. Regular inspection and testing of circuit breakers are recommended to verify their functionality and ensure that they are tripping correctly under fault conditions. Regular maintenance can help prevent nuisance tripping, which can disrupt operations and cause inconvenience. Coordination studies play a vital role in larger electrical systems, ensuring that overcurrent protection devices are properly coordinated to minimize the impact of faults. These studies involve analyzing the fault current characteristics of the system and selecting overcurrent protection devices that will trip selectively. Selective coordination means that the overcurrent protection device closest to the fault will trip first, isolating the fault and preventing upstream devices from tripping unnecessarily. This minimizes the extent of the outage and improves the overall reliability of the electrical system. By understanding the principles of overcurrent protection and following best practices for selection, installation, and maintenance, electrical engineers and technicians can ensure the safety and reliability of electrical systems. Fuses and circuit breakers are essential components of these systems, providing critical protection against overloads and short circuits. When dealing with electrical panels, the continuous load on any overcurrent device should not exceed 80% of the device rating if the overcurrent devices are standard thermal-magnetic breakers. For example, if you have a 20 amp breaker, the maximum continuous load should not exceed 16 amps. This is because standard thermal-magnetic breakers are designed to trip at 100% of their rating, but they are not designed to carry that much current continuously. There are overcurrent protective devices such as breakers that are rated to operate at 100% of their rating, but these would be specifically identified and are not standard. Article 210.19 A1 of the National Electrical Code, or NEC, and Article 215.2 A1 talk about the 80% rule when dealing with branch circuits and feeders, respectively. Also, Article 384.13 discusses the 80% rule when dealing with switch and panel board overcurrent protection. The 80% rule is in place to prevent the overcurrent protective device from overheating and tripping unnecessarily. It also provides a safety margin in case of unexpected overloads. The interrupting rating is how much current a fuse or breaker can safely interrupt. If a fault current exceeds the interrupting rating of the fuse or breaker, the device can fail catastrophically, potentially causing a fire or explosion. It is important to note that the interrupting rating is not the same as the continuous current rating. The continuous current rating is the maximum current that the fuse or breaker can carry continuously without tripping. The interrupting rating is the maximum current that the fuse or breaker can safely interrupt. The selection of fuses and circuit breakers is based on factors such as the voltage, current, and interrupting rating of the circuit. It is important to select the correct type and size of fuse or circuit breaker for the application to ensure that the circuit is properly protected.